Hi, everybody. Welcome to English Digest. I'm Stephanie.
I'm Tom.
Hey, it's our environment unit. So what are we going to talk about today? Well, we've got scientists who have created synthetic trees to help dry areas. They're trying to come up with a technology to draw water up from deep in the ground to help very dry areas of the world, which is really cool.
So we are talking about synthetic trees or artificial trees that are going to help dry areas of the world. So let's find out what this is all about. Let's read the entire contents of our lesson right now, and then we'll come back to discuss it. Have you ever stuck a straw in a drink and noticed the liquid creep up the inside a short distance? If so, you've observed the capillary effect. This phenomenon occurs because water molecules are attracted to various substances, including glass and plastic. Trees use the capillary effect to suck water from deep in the ground. Researchers at Virginia Tech in the U.S. have used this idea to create a device that operates in the same way and can thus provide clean drinking water to dry regions. The device, described as a synthetic tree, comprises 19 miniature tubes in a clear plastic box. The lower ends of the tubes sit in a container of water, but in the real world, they'd be inserted into the soil. Above these tubes is a ceramic disc, which acts like the leaf of the synthetic tree. Like a real leaf, it is full of holes, which allows the water taken up by the tubes to evaporate. Not only does this allow the water to enter the air, but it also makes the sucking action of the capillary effect stronger. To boost the evaporation rate, the disc is covered with a thin layer of graphite that absorbs more heat generated by a solar lamp. The water in the air is then collected with the aid of a cooling plate placed above a separate chamber. It's estimated that a synthetic tree could draw water from as far down as 100 meters below the surface. The Virginia Tech team also believes that 1 square meter of leaf might produce 1.6 liters of water an hour. While the synthetic tree needs more development to ensure it can work on a large scale in the real world, the scientific community is hopeful. For one thing, it could be used in arid regions where clean water is found deep underground. For another, it could be modified to include a membrane to filter out salt, making it usable near the ocean. Countless lives would be improved if the promise of synthetic trees can truly bear fruit.
Okay, guys, let's get started. First, we're going to look at the title. We have a vocabulary word right there. Scientists create synthetic trees to help dry areas. So if it's synthetic, it's not real. It's made through some sort of chemical process. We could call it artificial or fake. These are man-made trees. They're not from nature. They're not natural. But these are supposed to help dry areas in the world that have difficulty even getting enough drinking water for the people, which is a big problem. It's hard to believe after all these years and all our technology that we still have people who don't have enough clean water. So here's kind of a scenario that our author is painting. Have you ever stuck a straw in a drink and noticed the liquid creep up the inside a short distance? I actually have. I've thought it's kind of interesting how that works. So if something creeps up, it just means it's moving very slowly. Sometimes we creep around because we don't want to make any noise. For example, on Christmas Eve, I have to admit, my brothers and sisters and I, we would creep downstairs very early in the morning so that our parents couldn't hear us. We wanted to see if Santa had been by to deliver our gifts. And we weren't supposed to get up, at 4 a.m. That's when we were creeping down the stairs. So if you creep, you're just moving very slowly and quietly. This liquid is creeping up inside the straw, but it's just a little bit of a distance. So it's just creeping up a short distance. If so, it says here we've observed the capillary effect. A capillary is a blood vessel. It's a very small, tiny blood vessel that feeds into our veins and arteries.
And capillary does have to do with blood vessels and tubes. So this is a phenomenon that happens inside of tubes. So indeed, you may have stuck a straw into your drink and the water kind of crept up inside a short distance. And that's an example of the capillary effect. Now, what causes that? Well, this phenomenon occurs. This happens because water molecules are attracted to various substances, including glass and plastic. So the straw is made out of plastic, and then the water inside the straw is attracted to plastic that's farther up the straw, so it kind of goes up a little bit until gravity moves it back down again. And trees use the capillary effect to suck water from deep in the ground. So you may have wondered that. Trees are planted in the earth, and somehow they manage to get water from the ground and move it upward. But, well, how does that work? Because water's heavy, and gravity should be keeping the water down. How do trees manage to suck it up? There's nobody sticking their mouth on the top of the tree and sucking in like a straw to make the water go up into the tree. The tree is doing itself. It's doing that itself somehow, and I guess it's doing that with the capillary effect.
It's so amazing. I think a lot of our scientific inventions have come about because of scientists observing nature and how nature acts and then trying to copy that through a man-made process. So they use the capillary effect to suck water from deep in the ground. Sometimes those trees have really long, deep roots, trying to find the water that they can. Researchers at a university in the U.S., the university is called Virginia Tech. Anytime you see a university or college name with tech on it, you know that there's a lot of scientific research and discovery going on there. A lot of those kids at some sort of tech college or tech university will end up either being professors of science in some sort of other school or becoming researchers and scientists. So these researchers at Virginia Tech have used the idea of a tree sucking up that water from deep in the ground to create a device, some sort of instrument that operates in the same way and can thus provide clean drinking water to dry regions. I mentioned this at the start. There are still places in this world that don't have access to clean drinking water, which is really hard to even think about based on the billions of dollars we've given as donations and charity, that they still have places that don't have access to clean water. I'm wondering where all that money is going.
Me too, but of course, sometimes in dry areas there is water there, but they just can't get to it.
Yeah.
It's under the ground. So this technology may be a way for people to get that water out of the ground and into their tummies so they don't have to be thirsty all day. So again, this device operates in the same way and can provide that clean drinking water to people who live in dry regions, like where there are deserts and stuff like that. Now, moving on, the device, described as a synthetic tree, comprises 19 miniature tubes in a clear plastic box. So it's not really a tree, but they're describing it as a synthetic tree. It acts like a tree, even though I don't think it looks anything like a tree.
Yeah.
But it's made up of, or it comprises, 19 miniature tubes. To comprise here just means it's made up of those things. It has them as the building blocks for that thing. So it comprises 19 miniature tubes. And miniature here is a word that describes something that's very small, or at least smaller than something else. And I think some people probably say miniature. They kind of shorten it down to 3 syllables. But technically, you're supposed to say miniature, but you will hear miniature when people are talking fast.
Yeah, I say miniature. So miniature, yeah, they're really tiny tubes, and they are in a clear plastic box. I think that box is supposed to represent soil. So the lower ends of the tubes then sit they sit in a container of water. So in the real world, of course, they would be inserted or placed into the soil. To insert just means to take something and place it inside something else. Maybe you're listening to a CD and you open your CD player and insert a new disc. So you can insert lots of things into something else. So place or put something into another thing is to insert. So in the real world, if they weren't just doing an experiment, of course, these tubes would be inserted directly into the soil and not just in a container of water. That container of water is supposed to be acting as if it's soil or ground. Now, above these tubes is a ceramic disc. Ceramic means made out of some sort of clay that's been hardened. And a disc can be any sort of round, flat shape. A disc is something like a CD. We spell it differently for CDs that we listen to get our music on. Nowadays, everyone's just downloading MP3s or streaming music, but I know people still know what CDs are. That disc is the shape of what we're talking about, a ceramic disc, and it acts like the leaf of the synthetic tree. So pretend that flat disc that they're using is actually a leaf.
But it isn't, but it acts like a leaf. And we'll continue talking about this device as our lesson continues. But right now we're going to take a break and listen to our Chinese teachers. Stay tuned.
听众朋友大家好，我是安娜。其实我们都知道现在这个极端气候为地球的这个整个环境带来很大的变化。然后呢，有一些地方呢常常都干旱，然后就缺水。这时候怎么办呢？其实最近有新发明叫做合成树。合成树可以带来更多的水资源这个合成树出现在标题当中，我们一定要认得它 synthetic trees。Synthetic trees 合成树。那合成树它到底是利用什么样的原理才能够有水呢？这个原理就出现在第一段第二句的地方，其实是利用毛细现象。第二句大概句尾的地方我们看到 the capillary effect。The capillary effect 毛细现象我们都知道嘛，就是这个小小的管子或者是像毛巾这种小小的这样子的细管呢，水会一直不断的往上。那这种现象当然是因为水分子就会被各种东西吸引不管是玻璃或者是塑胶。所以呢，美国 Virginia Tech 它理工学院的这些研究人员就用这种想法来创造一种相似的运作方式的这种装置，就可以替干燥地区提供很干净的饮水好，那这样子的装置呢，就是被称为所谓的合成树，它出现在第二段第一句的地方。不过主词 the device 逗点之后出现一个关系子句的简化 described 前面本来有 which 或者是 that。is 关系词跟 be 动词整个省略，被描述成为或者是被称为所谓的合成树的这种装置呢，它其实是有19根微型的管，微管组成这样子的一个合成树，然后装在一个透明的塑胶盒当中。管子比较低的末端就会放在盛水的容器当中，当然在现实世界里就是插到土壤里啦。那么在这些管子的上面就是一个陶瓷圆盘，这个圆盘的作用呢，就好像是合成树的叶子一样。
We're going to take a quick break. Stay tuned. We'll be right back.
Okay, welcome back, everybody. We're talking about this synthetic tree that can suck water out of the ground in dry regions so that people can have drinking water. And we've been talking about how this device works. It's very technical here. I'd like to actually see a video describing how this works. But in any case here, what we've got is a synthetic tree. It's got 19 miniature tubes in a clear plastic box. The lower ends of the tubes are in the container of water. If it were the real world, they'd be in the soil. And then we've got this ceramic disc above the tubes, and that acts like a leaf. and that's the leaf of the synthetic tree, even though it's not really a leaf, or it's not shaped like a leaf, it's shaped like a disc. And like a real leaf, it is full of holes, which allows the water taken up by the tubes to evaporate. So I guess that's how a real leaf works. It's full of holes. And then in this particular case, when the water is inside the leaf or the disc, then the water can evaporate. I guess that's a good thing. To evaporate means to become a gas. It's for a liquid. When a liquid becomes a gas, it evaporates. So, of course, after a rainstorm on a hot summer day, you see water on the ground, but it very quickly dries up because all that water evaporates. It just goes back into the air as water vapor.
So not only does this allow the water to enter the air, but it also makes the sucking action of the capillary effect stronger. So all of these parts and elements of this particular device work together to produce this water. Now, to boost or to increase the evaporation rate, turning liquid into gas or some sort of vapor, the disc is covered with a thin layer of graphite. And that graphite absorbs or takes in more heat generated by a solar lamp. So this has different parts to it, doesn't it? Now, graphite is a form of carbon, and it takes in that heat that is produced by a solar lamp that they're using on this particular device.
Exactly. So graphite, of course, is in your pencils. And so we've got a thin layer of graphite, and it sucks in the heat. It absorbs more heat generated by a solar lamp. So we've got a lamp there that is solar powered, and the water in the air is then collected with the aid of a cooling plate placed above a separate chamber. So, of course, the water evaporates, and you don't want the water to escape into the atmosphere. So the water in the air will then be collected with the help or with the aid of a cooling plate. And that cooling plate is placed above a separate chamber. So this is all very technical again, but basically what we're doing is we're sucking water out of the ground. It turns into vapor, it evaporates, and then it turns back into a liquid using these various technological steps.
Very interesting. So it's that cooling plate that's placed above a separate chamber. Remember, chamber is an enclosed space. That's when we use that word. That's when the water is collected. So moving on to the final paragraph, it's estimated that a synthetic tree, or this device we're talking about or describing, could draw water from as far down as 100 meters below the surface. That's a long distance to be drawing this water up. But if you estimate something, it means you're giving something a big guess. You've got a lot of information that you need, but maybe it's not complete. Maybe it's just a rough calculation that you're coming up with. So based on the information that you have, you judge something to be of value. It's an estimation. That's the noun form. So an estimation, again, is not exact, but it's a close or very good guess. It's a rough guess, but it's a guess that comes after you have a little bit of information. So, wow, that's a long way down from the surface that these little tubes are able to draw up water. This would be really helpful.
Yeah, in some places, of course, the water table may be quite deep.
Yeah.
So if it can go down there quite deep and suck up that water, that's good for an area that doesn't have a lot of its own water. And the Virginia Tech team, this group of people working together, they also believe that 1 square meter of leaf might produce 1.6 liters of water an hour. So that leaf, again, that disc, could be larger. It could be 1 square meter. Which is fairly large, but that could produce about 1.6 liters of water per hour. That may not sound like a lot, but if you have an area like in the desert or something, and you have a lot of these things spread out, that could mean quite a lot of water. And that's just 1.6 liters an hour. Imagine how many liters of water that would be in a whole day.
It's pretty impressive. Now, while the synthetic tree needs more development, they're not finished with it. They're still working on it. That's how these experiments go. They need more development. Why? Well, to make sure or to ensure it can work on a large scale in the real world. The scientific community is hopeful. When you talk about a scientific community, it's just the group of scientists that are currently working on a particular area of science. And of course, the scientists that have been concerned about coming up with better ways to procure or gather water would all be very interested in this particular experiment and research that's going on. So it's got these particular scientists who keep in touch with each other and follow up on each other's work. It's gotten them quite hopeful. So it sounds like it's looking very positive, you could say. We're not sure it's going to change the world yet, but it looks positive. For one thing, here's one reason why they're hopeful. It could be used in arid regions. Arid means a place that doesn't have a lot of water. I grew up in an arid region of the world. In Arizona, we do have mountains and lots of water in northern Arizona, but in southern Arizona, it's quite a dry desert. It's beautiful, though.
Yeah, I was going to ask you where you get your water there in the Phoenix area.
It comes from canals and from the Colorado River. We borrow water from California and Colorado. But yeah, we need more water. So this is kind of an exciting thing to be seen. Where these researchers and scientists are making a lot of progress. So arid regions, again, just where there's not much water naturally to be found. This could help these arid regions where clean water is found deep underground. So they do have water, but it's quite deep, and to get it out is it's kind of a mess. So this could really help these areas.
Indeed, and I think I've also read about various technologies in the past that can get moisture out of the atmosphere. Of course, the air in arid regions may have water in it, so they are working on ways to get water out of the air as well. And I guess they're also working on ways to get carbon out of the air. But in this particular case, they're actually sucking the water up from water that is underground somewhere. So the scientific community is hopeful, but it's still pretty early here. They need more development. And for one thing, it could be used in arid regions, as you said, where clean water is found deep underground. I guess in some places, water is not found deep underground. They'd have to look for other solutions. And for another, it could be modified to include a membrane to filter out salt, making it usable near the ocean. So if you modify something, you make a little bit of a change to it so that it can perform a different kind of function. You might modify your car, for example, to make it go faster or something.
Yeah, and when you filter something, it means you're passing some sort of substance through to take out or remove things that you don't want. So you'd want to filter out salt and other things that would make the drinking water undrinkable. A membrane is usually a very sheet-like, thin layer of something that can help you filter out or keep things that you don't want in your water out of the final product. So this would make it usable near the ocean. It says countless lives would be improved if the promise of synthetic trees can truly bear fruit. To bear fruit is a phrase we use just to mean to produce results. So we're hoping that this research continues to be positive, and they go on to have a lot of success in helping regions around the earth have drinkable water. We're sending them lots of good wishes.
And sometimes we lack water here in Taiwan, so maybe we could learn a thing or two from this technology. Okay, that brings us to the end of our lesson for today. It's time now to listen to our Chinese teacher.
而且啊，其实这个陶瓷圆盘就跟真正的叶子一样，布满了孔洞哦，可以让管子带上来的水蒸发。好，我们看一下同样第二段第4句的地方，这里出现了一个也是补充说明的关系子句，先行词是holes 就是小洞，后面呢逗点之后的 which 一直到句尾可以左右挂号起来，它也是补充说明这些洞什么样的作用呢？这个洞啊就可以让水带上去蒸发。 好，接下来我们看到，那这样子的一个作用呢，就可以让水进入空气当中，它也可以让毛细现象的吸力是更强的，因为当水带上去之后，那如果这个洞呢可以往上再抽，那么整个水就会上来。那中文这样讲，英文写的是有一点困难的，因为第二段的这个第5句，我们来看一下，又出现倒装了。在这里的倒装并不是我们刚刚说的地方副词放句首的倒装哦，我们看到的是 not 否定字放句首的倒装。否定字放句首的倒装很有可能就会借助动词出来咯，因为它看起来很像疑问句耶。我们来看一下这一句 Not only does this allow the water to enter the air。 好，我们看到其实真正句的主词是 this， 也就是布满孔洞这一件事情，动词是 allow 允许，但是因为要变成倒装的关系，所以借了助动词 does 出来。那么在 not only but also 不止 A 而且 B 这样的片语当中， but 之后的句子是不需要倒装的哦，我们要倒装的是 not only 本身的这个子句，所以逗点之后我们看到的But it also makes 是句子正常的排列，没有倒装。好，那么为了要提高蒸发率啊，圆盘上还会覆盖着薄薄的石墨，就可以吸收更多太阳能所产生的热能。那么当然据估计啦，如果我们造一个合成树的话，其实就可以从地表下100公尺深处来吸水上来哦。接下来我们在第3段的地方，第一句看到一个虚主词的句型， it 是虚主词，真主词从后面 that 一直到句尾的地方可以用中括号，中括号就是名词子句的概念。不过在这个名词子句当中，我们还是看到一个比喻的句型 as far down as， 后面的 as 是像的意思，就是有像大概100公尺那么深哦，可以从那里来取水出来。好，那么当然合成树需要更多的发展，才能确保在真实世界当中可以大规模的运转。不过大家对这件事情还是充满了希望。好，为什么呢？因为一方面呢，是因为可以取到干净的水源，二方面其实还可以过滤盐分，搞不好在海洋地方也可以使用诶。我们看一下最后一段第5句，逗点之后有一个 making， 它是个分词构句哦，但是你看它分词构句，其实还原是个关系子句的简化。怎么说呢？从整个文意上去判断，其实逗点之后的 making 应该是 which makes， 而 which 指的是前面整个句子从 it 一直到 salt 的地方，所以并不是看到逗点 ing都叫做分词构句，在这里是一个关系子句的简化，而 which 代替的是逗点前面整个句子。以上是我们今天的内容，我是安娜，我们下次见。
That is it for today's program. Thanks so much for joining us, and please join us again next time for another edition of our program. And please don't waste water if you don't have to. From all of us here at English Digest, I'm Tom.
I'm Stephanie.
Goodbye.
Bye.